All right, so we have an interesting problem here for a microwave circuit design course. We have a four-port network which has the following scattering matrix. Part A asks, what is the return loss at port 1 when all other ports are terminated with matched loads? So part A, first I want to get a visual of the four-port network. So I'll take this here. Right, this is what the four-port network looks like. And we want to find the return loss. So return loss is equivalent to minus 20 log magnitude of the reflection coefficient in dB. We know that the return loss is equivalent to an incident wave, a reflected wave over an incident wave, which is equivalent to ZL minus Z naught, ZL plus Z naught, when ZL equal to Z naught. This is the matched case, meaning gamma L equal to 0. Also, V0 minus is equivalent to gamma V0 plus. In this case, since gamma is 0 for the matched condition, V0 minus is 0, so this means that there's no reflected waves. So when all other ports are terminated with matched loads, we have V3 minus is 0, V4 minus is 0, V2 minus is 0. So the return loss is really just asking the question of how much reflection there is at port 1. So we introduce a signal into port 1, we call this V1 plus, and measure what comes out of port 1, which is V1 minus. We're really asking V1 minus over V1 plus equal to S11. The return loss will be equivalent to minus 20 log magnitude of S11. And I drew this matrix that represents all the data from the scattering matrix, or all the positions for S11, S21, S31, S41. So our S11 is here. So the magnitude of S11 will be 0.178. So the return loss is equal to minus 20 log of 0.178, which is approximately 15 dB. And so that's part 1.